we'll look at the best orientation for the part to see how it should be built. So, for example, if you have a hollow tube, then typically it's best if it's built vertically with the circle of the tube running across the machine. So the long axis of the tube is vertical. So once we've orientated the part, then it will be sliced, and this means that the computer basically just hacks it up into 0.15 or 0.1 millimeter layers, depending on how thick we choose to build the part or layers we choose to build. That then is that information is sent to the machine, and this is really the way that the EOS machines work. All of the slicing is done prior to sending the data down to the machines, whereas with the DTM machines, in fact, the slicing work is done on the machine. The machine will then take the data and build it back up a layer at a time. And the way that works is essentially the SLS process uses a hollow tube which has got a platform in it which drops down in small increments of typically 0.15 or 0.1 of a millimeter. Cold powder is put and laid evenly in a layer on the top of that platform and then heated up to just below the melting temperature of the nylon. Then the building process takes place as a result of the infrared laser being scanned over the surface in the areas that you need to be melted. So what the laser is doing is it's just tipping the temperature over the melting point of the nylon. So you then have areas of the nylon that are molten and areas that are just still powder. The next thing that happens is that the powder, so the molten nylon, cools down. The platform drops down one layer thickness, say 0.15 of a millimeter, and cold powder is rolled over or spread over the surface, and that crystallizes the molten layer beneath. The process is then begun all over again. The new layer is heated up, the laser scans over the surface and melts the new layer, bonding it to the layer beneath. And if you carry on doing that, then eventually you end up with the completed part.